Welcome to Claxton's knowledge sharing webinar entitled Asset Integrity Services for the Oil and Gas Industry, the Main Challenges. The function to submit questions is available and answered at the end of the sessions, or collated, answered and emailed to attendees should we run out of time. So let's get started. Who are Claxton and what do we do? Claxton, an ACTEON company, combines a fast-track design and project engineering service with a large, rapid call-off inventory to deliver integrated end-to-end solutions for our clients' upstream projects all around the world. Established in 1985, Claxton has unrivaled knowledge and 30-plus years of experience delivering innovative, class-leading offshore engineering solutions by responding to industry needs. We understand that operators are under increasing pressure to reduce costs and optimize asset performance, which is why our experience, coupled with extensive in-house tailored engineering capabilities and a proven record of managing successful campaigns, makes Claxton the confident choice for upstream projects. Therefore, we're very pleased to welcome our notable expert, Anne Vicens, Project Leader for Centralizers and Asset Life Extension. With a bachelor's degree in industrial engineering, Anne has worked in the industry for over 15 years, starting as a field engineer through to project management to now a technical lead position. Over the years, Anne has worked together with a number of clients across the world to manage and advise on asset life extension campaigns, utilising her innate understanding, experience and knowledge to add significant value at all stages of a project, as this presentation will demonstrate today. Over to Anne.
Thank you, Maria. As Maria was mentioning just now, the purpose of this presentation is to go through the main challenges, and those main challenges really are not our challenges, but the clients that our clients and the industry is facing, and we receive sort of repeated type of inquiries on some themes in specific regions, and some of them actually are quite global issues as well. So we'll just be covering through some of them, and after that we'll just go through the conclusions, and hopefully we'll have time for some questions as well. And we'll just finish with a quick word on ACTEON Integrated Services overview. So, asset integrity versus asset life extension. I suppose that's a question that we sometimes receive. In reality, asset integrity covers the integrity of the asset through its whole life. And asset life extension is evaluating the integrity of the asset to allow the asset to be to have its life extended an additional number of years above the originally intended design life. So they're both very much sort of together, really. You cannot have a life extension without taking care of the integrity of the asset. But important to understand that asset integrity has to start from the beginning with the original design of any of your equipment. So this is that asset integrity is not something, or asset integrity issues is not something that we see is going to decrease at all in the future. If anything, the number of assets in the North Sea have been with the number of years have been basically increasing through the years. So that means that as assets get older, then more issues will basically be arising. So this is a trend that we have seen not just only in the North Sea, but also we've seen in other regions around the world. So there's clearly quite a lot of interest and a necessity for this area to be continuously developed, and more methodologies developed as well. So as mentioned before, asset integrity includes initial design considerations, and by that I mean how originally when you're designing the asset, to think how easy it is going to be to carry out maintenance on the equipment, how easy it is to access the different parts that might need to have maintenance as well. So all of these things have to be taken in consideration really early on. As the word might sort of indicate, caring for assets is also providing it sufficient maintenance throughout the design life so that it always operates to the required level. Managing the structural integrity of the asset is a big concern of many operators and duty holders. And the way they try to carry out this is by understanding and mitigating the risk. And you might have seen a trend in conferences, websites, in the industry in general, of increasing the number of programs that look at carrying out inspections based on risk. Because the trouble is, of course, everybody has limited budgets and resources. So to make better use of them, then a risk approach to prioritize activities is recommended. Keeping adequate records is also very important, and it can be quite tricky, in particular on old assets where perhaps the original records are no longer available. Some of them might be missing. Also, the formats in which they might have been prepared and saved might not just be compatible. So, and then some of the information, as I said, might be incomplete. So, although you might be able to find some of the information on the asset, you don't really have like 100% guarantee that what the drawing says the latest condition of the equipment. For asset life integrity as well, something that you might want to consider is future modifications. So how easy would it be to modify, say, for example, if you want to carry an upgrade, or if you want to add a new well to your asset, how easy would that be to carry out with the original design? And of course, as time moves on and we learn more about the industry, about potential risk, then it's natural that legislation and standards change as well. So it's important to consider this as well, so to make sure that we're always up to date with the legislation requirements and standards. So the first challenge that we hear quite a bit about is this one. Is besides decommissioning, what other options do I have to address a well not producing to a financially viable level? So there's different reasons why this could be. It could be basically your well is basically depleted and it's no longer producing to a level that is actually producing benefits. Or perhaps actually now you might have other assets that could potentially be producing more using the same number. So when comparing your different investments, then perhaps this one no longer is as attractive as initially it was. Or then it might be just, you might just have issues with the actual well and it's time to actually having to spend a lot of money on it to continue producing. So one thing that you can do is to reutilize the existing slot of the guide to run a new well. So to do that, the first thing that you have to do is to carry out a slot recovery of the well. So for that initial stage of the slot recovery, then we do have a range of coating and retrieval packages available, and there's more in the industry that can be used to carry out that activity with or without a rig. Then there's different options for reutilizing that. You can potentially use a whipstock, which basically is a mean of deviating the new well in a different direction to avoid the old one. And there's subsea ones, or there are some whipstocks that can be done above mud line as well. But the important thing, of course, is to make sure that the new well will not interface negatively with the other adjacent wells or the structural members of the platform. Now, if as an alternative for an above seabed whipstock, we also have a conductor deflection tool. The reason why you would perhaps use this is if your platform cannot take the additional loads of running a new conductor, then this tool basically allows you to control those additional installation loads of the conductor within the tool, so to avoid transferring those loads. And basically what it means is that the only loads that your platform would see are the original ones, in the ones that you originally considered for the design, which will be the environmental loads. For all of these type of activities, very important to try to initiate conversations between duty holders and service companies and contractors as early as possible, because there's a lot of interfaces, not just with the existing well, but also with the installation vessel, etc., that it's important to actually set from as early as possible, basically. Just to show you here a little bit what this conductor deflection tool looks like. The diagram here shows it a little bit. You will see that the tool is of a tubular form, and you will notice there's a window cut in between the tools. So the intention is then the conductor is run through that window, and basically then interfaces with the section at the bottom with the chamfer, which will be the sort of slight whipstock segment of the tool, really, which is in blue, is shown in blue in the diagram. So the conductor then the conductor then deflects at that point, and of course the tool is orientated in the right direction, so to avoid collision with any adjacent wells or structural members of the platform. The second challenge: how can I increase the number of well slots within my platform? So clients might already have a platform that is still producing quite well, but they would like to get a new well. Of course, if you already have an asset and you can try to reutilize some of its members to run a new well, that's going to be considerably cheaper than looking for alternative options. So one way of doing this is by including an additional guide slot within the existing area of wells or adjacent within the structure. So if you see the picture there, that shows an example of an additional guide installed. The idea is that you look at your platform, you look at your available space between your main tubulars and see where you could potentially feed a new well. Of course, this type of activity requires a lot of initial analysis to make sure that the work that you carry out is not going to have a negative effect on adjacent wells or in the actual performance of the structure. So one thing as well that is important to consider with this is that it's highly recommended to carry out a survey as early as possible, because as I mentioned before, sometimes the data is not 100% reliable. If you can imagine, installing something at the splashdown level normally requires rope access operations or fitting some scaffolding. So it's an additional activity. So it's important to carry out that survey as soon as possible, not only to make sure that what you design is going to fit properly, but also to look at ways on how better to install, so the methodology of installation as well. The next problem is conductors basically moving around the guides. So of course this is a cause of concern for clients, thinking that perhaps they're going to fail and going to cause damage. And this is a problem that we are very used to dealing with, and it's quite a common problem, and it's due to basically poor lateral support for the conductors. So initially, one of the things that we recommend is conducting a survey to determine if there's any damage that has been done to either the conductor or the guides. And also that survey will determine as well if the level of centralization available for the conductor at all the different guide levels. It's interesting to see that sometimes clients contact us because they see a lot of movement at the cellar deck level and they think that is the problem, but sometimes that's just a symptom of poor centralization, perhaps in other levels, typically the splashdown level. So that's why it's important to carry out that initial survey to determine really what the situation is. So depending on what is found on the survey and what needs to be addressed, and there's different designs of retrofit designs to centralize. By centralize, I mean like basically take care of that big clearance to reduce the clearance, and in this way avoid the excessive movement of the conductor within the guide. Of course, these are retrofit designs because the conductor is already in place. So this way, basically, you install something already with a conductor already in place, and there's different ways of trying to avoid existing equipment as well. The next challenge is finding a cost-effective solution to extend the life of the wells. So the problems vary again quite a lot. So there can be different types of problems, and it might seem obvious, but the first thing really is determine the current condition of the asset, and that sometimes can be a lot more difficult than what it sounds like, because access to certain areas might be difficult to get to, because, as I said, there might be subsea, there might be the splash zone, there might be equipment that has been fitted since, and access is difficult. There might be it might be issues with the surface casing, for example. Then so visibility is an issue, so you have to get access and to determine the wall thickness of it, for example. So it comes with these challenges. So the objective of the life extension should also be clearly defined. And again, this might sound like something that is straightforward, but it's not, and it's important to determine this, because the tasks involved with extending the life of the asset another 5 years is very different from a project trying to reinstate the original integrity of the structure, for example. So this could be completely two different things, and the solutions could be very, very different. So it's important to determine what the objective is really. If you just need another 5 years before decommissioning, for example, then that has to be clearly stated. The cost-effective solution, it will be the one that actually addresses the problem, as opposed to just assume things. So, of course, there's always an element of conservatism in the designs, but you don't want to over-engineer too much the solution. You want something to be cost-effective. So that's why it seems so important to understand really what the problem is. How can I rehabilitate corroded conductors? Well, I mean, again, the extent of the damage is the first step really that needs to be carried out, because it could just be something very straightforward, or it could be like a big scope of work. So then after carrying out some basic inspection, you need to try to determine what the residual required design life for the conductor will be as well. And that's a little bit what I was saying for the previous slide. We need to know what is the requirement. Does it need to be there another 5 years? Does it need to be there another 25 years? Because of course, then what you actually need the equipment to be will be very, very different. So that could potentially also change quite drastically the type of solution that you need for dealing with your corroded conductor. Depending on the requirements, you might need just some basic fabric maintenance, so just coating, retrofit anodes, or potentially a more complex type of solution, or in an extreme case, the conductor might be in such a state that the best thing is actually to carry out a complete slot recovery of the conductor, and then basically try to utilize your slot for a new well, or just try to replace the whole segment, because basically the condition of the conductor is really bad. Here in this sketch, I'm just showing a quick type of solution that we have supplied for the Middle East. So this was done for a conductor that was highly corroded, and particularly in this splash zone, which is quite a common occurrence, because of course it's an area that has the three combination of having high corrosion, but with high environmental loads as well. So the first step is to determine the point at which the conductor is still in good condition. So determining the good section of conductor is important, because that's what's going to be utilized to install a clamp section of the system, and the clamp basically will work as an anchor for the rest of the system, which basically consists of a sleeve, and the sleeve is installed over the problem area to basically isolate the corroded part of the conductor. And there's a small gap that is allowed there where you basically inject some inhibitor material just to control the corrosion as well. So I mean, that's just an example of how to address corroded conductor. In this case, it's a method that prevents, basically means that you don't actually need to use a cofferdam, which I suppose is another one of the methods that are used also in the industry by basically providing a complete dry area to take care of the problem. But that can be quite costly and time inefficient as well. So this is an alternative to that. So we have seen quite a few examples there of some of the challenges that our clients have been facing. There's common themes definitely within the different problems on ways to tackle, and the common things is initially trying to really determine what the condition is and what the objective is. Again, sounds obvious, but it's something that we have seen in the past that perhaps sometimes is not as clear as it perhaps should be from the start goal, really. So there's definitely a requirement for continued developing methodologies to address asset integrity issues, because our wells are basically continuously getting older, so there's problems that need to be addressing. As I said, understanding the current condition sometimes is not as easy as we would like it to be, so it requires attention. A risk-based approach to define goals and prioritize tasks with limited budgets is the way to go, because it's you're addressing problems in a way that you can control your budgets a little bit better, but also you're making sure that you're keeping your equipment safe. But there's definitely further research and development required in the areas in general. That's something that we look forward to continue working with our clients and on other parties of the industry to try to improve that. So this was the presentation. It's quite a short one. Okay, we're running a little bit late for time, but thank you very much for providing all the questions. Just know that the ones that I don't address just now, what we'll do is I'll answer them, and then we'll send all the answers to all of those of you in attendance for this webinar. Yeah. So the first question I have here is there any preparatory work that needs to take place before using a whipstock or a Claxton tool? Yes, there's definitely some preparatory work. I suppose the bigger scope is the original well first need to be plugged and abandoned, and then the conductor retrieved. So that's the initial task, and that will be common regardless of which way you want to reutilize your well stock, if it's without subsea whipstock, over Modman whipstock, or using our tool as well. So that's a common thing. Another thing that could potentially be required, and that will depend on the elevations of each one of the guides, is you might need to actually remove some of the guides. And of course, this will depend, because if the lower guide, for example, is very close to the stump of the old conductor, then you might need to remove it to allow sufficient height for the new conductor to bend. So that's something, again, that has to be considered, and that will be something that we will be looking to work potentially with the client and with any other party that is carrying out some of the analytical work on it. But that's a typical preparatory work. And of course, the surveys, just to see how to access the area, available space, etc. So the usual type of scopes. Right, the second question I have here is how many new guides would you need to create for a new well with an existing platform? I suppose here you mean different levels of support. There's no one specific number of laterals, like guides, that you will need for a new well. The answer will basically will come after completing some analytical work. The arise analysis will typically look at environmental loads and will then define with the new sort of a configuration of your well what the adequate level of support will be for it. So to make sure that the fatigue life will be adequate for the design life required. So we have that capabilities within the group. One of our sister companies, 2H, can carry out some of the analysis, and then their output basically we will use for as our input for our design. So they might say that support at the station level alone is sufficient, or there might be a requirement for another guided subsea as well. So that can be done as well. So the important thing is just to have the analysis to support this. Also, not just to make sure the new well will be okay, but as I said during the presentation, also to make sure that it's not affecting negatively the performance of any adjacent wells or the structure itself of the platform of the jacket. I think this will be the final question because of time, but how can all non-performing centralizers be removed for the installation of a new one? Okay, this is something as well that we get contacted quite a bit with. Some of the assets, in particular in the North Sea, a lot of them have all centralizers that they have carried out their work because they now have more than exceeded its originally intended design life. But the fact is that the wells are still producing to a level that is satisfactory to the operators, and the overall condition of the asset is not bad. So you want to keep on producing from them, but there's an issue here with centralization that needs to be addressed. So we normally like to take a pragmatic approach to this, and removing in existing centralizers, especially those ones that have been pre-clamped to the conductor, where the bolts and the fasteners are located within the guide, is a very tricky activity to try to carry out. So it's not very practical trying to remove them. So what we try to do is to really tackle the problem, which is the excessive clearance. So we try to design equipment that interfaces with the guide, the conductor, and the existing centralizer in place, and that interfaces with all those elements to then reduce that clearance to an acceptable level. And that can be like a full centralizer that fit within the available gaps, or it can be the provision of engineered shims that feed and carry out the required activity. So that's how we normally go around approaching these tasks, because it's all about trying to make it as straightforward as possible to minimize as well the time offshore, when we know that a lot of the times things like bed space can be a challenge. So this we have seen has been the sort of the easier approach. So I think this is all we have time for now. I think there's just a couple of minutes now I'll pass you over back to Maria, that she has some final words on ACTEON.
Thank you, Anne. I hope you all found today's presentation useful. I would just like to end by explaining how Claxton is proud to be part of the ACTEON group of companies, a group committed to shaping and leading an evolving global subsea services market. ACTEON Subsea Asset Integrity Insurance Solutions provide independent, engineered for purpose and data-driven solutions for supporting subsea infrastructure. If your challenge or scope of work has not been covered in today's webinar, ACTEON Solutions can simplify the interface where customers need more than one of its operating company's products or services to address their subsea challenges. Each combination is packaged as a customer-specific integrated service and delivered through a single ACTEON point of contact under one single contract. If you would like to find out more about ACTEON, please visit their website at www.acteon.com, or we can put you in contact with the relevant technical authority. I hope you all found today's presentation useful. And finally, at Claxton we're always eager to offer advice on a broad range of subjects, But if you have specific themes or ideas that you'd like us to consider for webinars or blogs, please do let us know by submitting your questions to info@claxtonengineering.com. If you would also like to receive the latest information and news from Claxton, or wish to subscribe to our Thought Leadership blog, please visit www.claxtonengineering.com. And in the meantime, why not follow our social media channels, LinkedIn, Twitter and Facebook. Thank you again for attending today's session, and we look forward to seeing you at our next webinar. Goodbye.